The focus of this lesson is on composing functions together and then finding their domain. So we're going to go ahead and start off with the composition piece first. So we have the function f composed with g of x. So this is, you'd take your outside function, which in this case is f, and then you would evaluate it at g of x, and we say f of g of x. Okay. And what that means is now you need to go to function f, and wherever there's an x, you're going to replace it with g of x. So we know that g of x is square root of 4 minus x squared. So we just need to take function f, whatever it is, and evaluate it at the square root of 4 minus x squared. Well, f of x is x squared minus 4. Notice I didn't write in the x, and the reason I didn't write in the x is because I'm going to replace the x with what I'm evaluating at, which is the square root of 4 minus x squared. And then from there, so if you can let me just kind of explain this another way. Basically what you did is you used the skeleton of the outside function f and you evaluated it at the inside function g. So you use this skeleton, x squared minus 4, and you replace the x with the inside function square root of 4 minus x squared. And that's how composition always works. And then you just need to perform the operations. So if we take a square root and we square it, those are inverse operations, so they undo each other. And all you're left with is 4 minus x squared. And then you're subtracting off 4, so continue to subtract off 4. The 4 minus 4 cancels out to 0 and leaves you the negative x squared. So f composed with g of x is x squared. As far as the domain is concerned, there's two pieces you have to focus on. So you need to focus on the domain of the inside function. So the inside function in this case is function g. And then you need to focus on what appears to be, but may not be completely, the domain of f composed with g. In fact, that's what you're actually trying to find out. So we're just going to go off the initial appearance of f composed with g. So as far as the domain of g is concerned, we're going to look at our function g. So we're using the same g that we used in our composition. And g of x is the square root of 4 minus x squared. Now we know, as far as the domain goes, that if we're dealing with a square root, you have to take the square root of something that's either 0 or positive. You can't take the square root of a negative. So that means whatever's underneath the square root, which in this case is 4 minus x squared, that has to be greater than or equal to 0. So I'm going to subtract 4 from both sides so I could solve for x. I'm going to divide by -1 on both sides, which is going to cause my symbol to flip because I'm dividing by a negative. And then I'm going to take the square root of both sides. The square root of x squared is the absolute value of x, and the square root of 4 is 2, so the absolute value of x is less than or equal to 2, which splits into two inequalities. One is x is less than or equal to 2, so exactly what you see without the absolute value symbols. And the other is you remove the absolute value symbols, flip the symbol, the inequality symbol, and negate the other side. So both of these have to occur, and this is an and statement. So x is less than or equal to 2. So I'm going to kind of draw this so you can kind of visualize it. So here's -2, here's 2. And we need both inequalities to work. So x is less than or equal to 2. So that's all of this. And x is greater than or equal to -2. So that's all of this. So we need the intersection of those two, which is from -2 to 2. That's where those two shadings overlap. So the domain of G is -2 to 2, inclusive of both endpoints, hence the brackets. Now, if we consider f composed with G as we look at it, so f composed with G of x is -x squared. But that's just a polynomial or quadratic. And again, no matter what you put in for x, if you square it and then negate it, it'll still give you a real number output back. So no matter what real number you pick, it all works. If you square it and negate it, you'll still get a real output back. And so that domain is all real numbers. So now, to get the actual domain of f composed with G, not just what it appears to be, we need to actually take the intersection of both the inside function's domain and what it appeared to be the domain. So we need to actually determine that. So if we intersect these two domains, again, you can kind of draw it if it helps you. But the first, so I'm going to put -2 and 2 down. The first says the domain is between -2 and 2. The second says the domain is literally everything. So where do those two intersect? At -2 to 2. And so the domain for f composed with G is -2 to 2, because we took the intersection of the inside function's domain and what appeared to be the domain of f composed with G. So, but what was the actual domain of f composed with G? -2 to 2. So what that means is, at the end of the day, if you were to input any number in between -2 to 2 in for x, and you did this composition, you would get a real output back.